Welcome. In this lesson, we're going to study unconformities. An unconformity relates to the geologic history of rocks, and an unconformity is when rocks disappear. Our target or essential question for this lesson is what are the three types of unconformities, and how does each form? Just a recap of the last couple of times. In our first lesson, we learned about the three main ideas used to study Earth. So the rock record is providing evidence of geologic events and life forms of the past. That's primarily what we're studying about right now. Process observed on Earth also acted in the past, and Earth is very old and has changed over geologic time. We also talked about our three laws that govern rock and determining the relative age of rocks, so older and younger. Our first was superposition, where the oldest are on the bottom and the youngest are on the top. Our second is the principle of original horizontality, which says that rocks are usually horizontal, and then when they look like this, they must have been tilted or folded by plate tectonics. And our third was cross-cutting relationships, which stated that when an igneous intrusion, which means igneous rock shooting up, or a fault occurred where the rock breaks, if it cuts through layers, then it happened after those layers were already put down, so it's younger than all of the things that it cut through. Today we are going to talk about unconformities in the rock record. So an unconformity, vocab word, is a surface that represents a break in the rock record. If we break this word apart right here, we have un. The prefix un means not, and then we have the word conform. So an conform means to abide by the rules or follow along. So it's not conforming to our other rules that we had just talked about. Principle of cross-cutting relationships, original horizontality, and law of superposition. An unconformity is going to be a break in that rock record, and it can happen by a couple of different ways. The first is that deposition. Remember deposition like deposit, to put down. So our rocks stopped being laid down for a long period of time. And then erosion, which is when rock gets weathered away, has removed some previously formed rock. And then deposition, which is when rocks are being laid down again, has resumed. So this bullet point is saying that we stopped laying down rocks, and then some weathering occurred, something to happen like this dip right here, and then later more rock is going to be layered down in there. So we're missing all of these parts of the rock record that would have filled in this gap. There are three different types of unconformities or breaks in the rock record that we're going to discuss today. Our first one is an angular unconformity, and this is when the underlying older rocks, so we're talking about down here, and overlying younger strata up here show some angle with regard to one another. So this wiggly line right here is going to be our angular unconformity. The rocks below have been tilted or folded and no longer are originally horizontal. They no longer follow that process. And then there's an erosional surface, so there was some weathering right here. And then new flat rocks are deposited on top of that. You can see it in this bottom left picture. Here is where our rocks were tilted or folded, and you can see that they've been eroded away to form this flat surface where the principle of original horizontality is laying down or depositing more flat rock layers. In order for this to happen, we first have to have originally horizontal flat rock layers that get tilted or folded by pressure on each side, and then erosion will make this top layer flat again, and then we will have deposition of more sediments and get more flat layers on top. Here's another picture of an angular unconformity. Our rocks down here are at an angle, hence angular unconformity, and then there's an erosional surface right along the top where more layers have been deposited in the flat horizontal position, giving us an angular unconformity. All of these spots where these lines should have gone have disappeared from the rock record. Our next type of unconformity is a disconformity. A disconformity is when underlying or older, so down here, and overlying younger sedimentary rock up here are parallel, but the contact plane, so where they're touching, is an erosional surface. In this picture, what has happened is we had this orange layer, and then for some reason, our deposition stopped for a little bit, and we had some weathering and erosion, which removed part of, but not all of, this orange layer. Then deposition resumed, meaning we started putting down new layers of rock, and we got this break where the orange has been weathered away and purple has been placed on top of it. Here's another picture of a disconformity. The disconformity in this picture exists between which two layers? Right, this brick-like yellow layer and the green layer. Our brick layer was weathered away and deposition stopped, and then when deposition resumed, it made a new layer on top of it, deleting or removing some of this orangish brick layer. Our third type of unconformity is a nonconformity. A nonconformity is when the underlying rocks are igneous or metamorphic, down here. It says i.e. unstratified. So stratified means that our rocks follow that original horizontality idea. My lines are not horizontal. So when underlying rocks are igneous or metamorphic, i.e. unstratified, so they don't have these layers, and the overlying or younger rocks are sedimentary, stratified, meaning they have the layers, it's called a nonconformity. I remember this because it is a sedimentary rock and a non-sedimentary rock. In this picture, you can see our igneous rock down here, and it has an erosional surface, so magma was cooling, it created igneous rock, and then some weathering occurred, and then we had new layers of rock deposited on top of that, and they were stratified and sedimentary. So it is a sedimentary rock coming in contact with a non-sedimentary rock on the bottom. Here's another example of a nonconformity. In this picture, we have this igneous intrusion that came up. We can assume maybe that here some of this had eroded away and then sedimentary rock was laid down on top of it in layers. This would be our nonconformity. In this picture, I think it's taken in the Black Hills, all of this rock down here is going to be metamorphic rock, and then we have layers of sedimentary rock being placed on top, giving us a nonconformity. Going back to our essential question, which was what are the three types of unconformities and how does each form? Ensure that you can answer that. Please give your answer in the box now. Thanks.